Okay, good evening, good afternoon. It depends on where you're watching it from. We're looking at some past questions from Unilag. Here we have a question on calculus of several variables GG311. So we'll be looking at this question together. We are all here to learn. Nobody is perfect. Learning continues. Even if you are a professor, you keep learning until eternity. It's okay. So please, I want you to do me a favor, like, comment, and share. I'll be very grateful. Is that clear? And also subscribe. Is that clear? Okay, yeah, tonight we have a very beautiful question. The question here is, in the simulation of electromagnetic fields, vector field operations are essential. So consider the vector fields f of x comma y z equals to x squared minus y squared plus 2xy I plus xz minus xy plus yz close bracket j plus x squared plus z squared close bracket k. It says I compute the divergence d times f at the points 1, 1, 1. Then I say compute the coil of the coil cross coil f at this. So it's simple as ABC. So we are going to do it together, but we will start with the first one, I. It said compute the divergence. So what we are going to do is, let's write solution. Amen. Solution I. It implies that divergence dot f is equals to partial all over partial xi plus partial all over partial yj, take note, plus partial all over partial z k, then times vector function. This is what? F. This is the formula that you will use to obtain this II. Is that clear? I will make sure, break it down for you to know and understand it better. Is that clear? Amen? Okay. Yeah. So as you can see now, this is coil del. True or false? It means it is partial derivative. But we know that our vector vector function is given as this, which has how many variables? 3 variables, x, y, and z. True or false? Is okay. So if you agree with me, it means this implies that. Let's write it this way. So this means our del dot vector is equals to partial I all over partial x plus partial j all over partial y, then plus partial k all over partial z times what is the vector function? Is this right? So far so good. X square minus y square plus 2xy times I plus open bracket xz minus xy plus yz times j. Amen. Hope you are following. Then plus this x square plus z square close bracket k. Okay. Do you understand? Any question? Okay. So this implies that differentiate this vector function partially with respect to x, y, and z. Amen. Are you following? Any question? No question? Okay. So let us proceed to differentiate. It means this means that differentiate this with respect to x. Yeah. You go to j components. You differentiate it with respect to y. Look at it. You go to k component. Look at it. You differentiate it with respect to what? Z. That is how you are going to do it. Is that clear? Amen. It's okay. So let's go. Let's go. Any question? So this will now be equals to, we differentiate this here with respect to x. It means in this bracket we are going to have 2x. This function does not contain x, so here will be 0. We'll differentiate this. If we differentiate x, then whole 2y is 1. So 1 times 2y is 2y. So here will be plus 2y. Then this I and I will definitely vanish. So take note. You are not going to write I again. Please take note. But supposing here does not contain the vector function, that is when you remember this. But here there is vector function, there is vector here. Okay, then, so we are done with this with respect to x. So what else? Let's move to consider with respect to y. So we have to come to what? J component. Amen. So it means we are going to differentiate partially with respect to y. Please take note, very important. So if we differentiate, what we have here, plus, so plus, differentiate this with respect to y, here is 0 because there is no y here. Here, if you differentiate this with respect to y, you are going to have minus x, true or false? Because by the time you differentiate y, 1. So 1 times minus x is minus x, amen. Then plus what we have here, yz, then differentiate this idiot, whole z. By the time you differentiate y, you have 1, true or false? Then use it to multiply z. So here will be plus z, then close bracket, what we have here, plus, then with respect to what? Z. So we have to go to k components here. We have x squared plus z squared, true or false? So it means we are only going to differentiate with respect to z. So here is 0 because there is no z here. Then here, z squared. If you differentiate z squared, you are going to have 2z, true or false? Any question at this point before we proceed? Please, if you have any question, ask. Let me give you 30 seconds to do so. Ask your question, please. Ask your question. Any question? Yes or no? No question. So it means we can proceed, right? It's okay. If there's no question, let's proceed. Let us proceed. Okay. So far, so good. So, yeah. Since there is no question, let's proceed. But the question says, at the point It means we have x, y, z. So x equals to 1, y equals to 1, then z is equals to 1. So it means anywhere we see x, we substitute in 1. So therefore, the divergence will now be equals to x is 1, 2 open bracket 1, then plus 2 open bracket y is 1, amen. Then plus open brackets, here is minus, x is 1, so minus 1 plus 2, then plus, here is 2 open brackets, z is what? 1, amen. So what next is 2 times 1 will give us what? 2, right? So here will be 2 plus 2 times 1, 2. Then here, let's consider this bracket first. Minus 1 plus 2 is plus 1, amen. So here is plus 1. Then 2 times 1 is 2, amen. So 2 plus 2, 4. Plus 1, 5. Plus 2 is what? 7, right? So 7 is the final answer. Any question, please ask. I'm waiting. Any question? Do you have any question? Please ask. If you have any question, ask. Please. If there is no question, let us move further to consider the second question. That is II. Is there any question? No question? No question. It's okay. So let's proceed to consider the II. Yeah, the II, I will just show you how you are going to look at it. Can I clean the hub so that let me clean the hub. Clean the up so that we start from the up, amen. Okay. Okay. Yeah. So we are done with this I. We want to consider II. Let's consider II. Amen. Okay? Yeah. It's okay. So now I need to clean here. Okay. II, right? II. Cross vector function. Coil. Okay, yeah. They said compute the coil of the coil. So what we need to do here is remember in vector, as long as vector is concerned, when you see cross in vector, what should first come into your mind? Because you've been taught how to find magnitude of vectors and the rest. That is cross products and dot products. You were taught, two of us. So there's difference between dot and what? Cross product, two of us. So whenever you are asked to cross two vectors, it means they are telling you to look for what? The determinant, two of us. Okay, so if you agree with me, this implies that. Let us first consider this. So it means our coil cross vector now be equals to I, J, K. Then here will now be there will now be, will be partial all over partial X, then partial all over partial Y. And you see now, here will now be partial all over partial Z. Then our vector function F is, where is it? Okay, look at it here. Yeah, look at it here. So we have to write it here. Okay. I don't think this place will contain no. Let me just open it very well so that you understand it. I, let's write I, partial all over partial X. So our I function component is this. That is x squared, amen, minus y squared plus 2xy. So here will now be j partial all over partial y. So our j component is here. xz minus xy plus yz, amen. Then our k component is this, we write k, yeah, is this, that is x squared, sorry, here is partial all over partial z, right? So x squared plus z squared. Now you leave it this way. Can you see now? Can you see now? Any question, please? Ask your question. Just ask your question. It's okay. It seems there is no question you are following. Oh, we thank God for that. So this implies that you know how to find determinant of a given matrix, even in vector, true or false. So now, the reason why I want to consider this before this, because it is better for you to consider this, so that the result you use it to what? Get this again. Amen? Okay. So it means you are going to find determinant. How many times? 2 times. So let's look at it together. So far, so good. So here we are going to have cross F now be equals to, if you cover here, look at it. I know some of you are not familiar with determinants. How to take determinant of I. So I, you blind I, the row of the column of I and the row of I. It means here is blind. So what you are seeing, what are you seeing? You are seeing this, 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 and this. True or false? So this implies that I, open bracket. It means if you use this to multiply, okay, let me just break it down for you. Is that clear? So that you won't be confused. It's okay. So here, this multiply this minus this times this. So here will be partial all over partial y, open bracket, x squared plus z squared. Amen? Okay? Then minus partial, this one multiply this, partial all over z, open bracket, x, z minus xy plus yz. Amen? Okay. So let us find I, determinant of I. Amen? But here we are working with, here is plus, minus, plus, as long as determinant is concerned. Take note. So it means minus what? Let us close the bracket minus I, amen. Then it means the same thing applicable. We close the row and the column. So what are you seeing? I believe you can see this, and this, two of us. So this will multiply this will multiply this, minus. So we are going to have partial all over partial x, am I right? Times x squared plus z squared. Yeah. Then this times this minus partial all over partial z, open bracket, x squared minus y squared plus 2xy. Amen. Then close the bracket of I, then plus k, open bracket, the same thing applicable. We close this. So what are you seeing? You are seeing this, and this. Two of us. Any question, please? Do you have any question? Any question? No question? It's okay. So if you agree with me, it means this will multiply this minus. So here we are going to have partial all over partial x times this, right? xz minus xy plus yz, then minus this times this, partial all over partial y, open bracket, x squared minus y squared plus 2xy, close brackets. True or false? True or false? True, right? It's okay. So can we clean this so that can contain what we are trying to do? Okay. Yeah. But let me not clean this. Let me not clean the question. Let me leave it. Okay. So far, so good. It means this will now be equals to. This implies that differentiate what is inside there with respect to y. For the fact that there is no y, here will be 0. Is that clear? Take note. So here will be 0. Then here, differentiate what is inside here with respect to what? Z. Here, if you differentiate with respect to z, we are going to have x. Here will be 0. Here will be y. True or false? But mind you, we have minus here. So there will be minus I, open bracket, x plus y. You agree with me? Then minus j, right? Differentiate this with respect to x. So when you differentiate this with respect to x, here will be 0. Why? Because there is no x. So here we are going to have 2 minus j. Oh, sorry. This is j, not I. Please take note. Minus I, j, open bracket, here with respect to x, we are going to have 2x. Then, here, with respect to z, we discovered that z is not here, true or false. So here, if you differentiate with respect to z, here will be 0. So, just leave it like this. Then, come to k. Plus k, right? Plus k. Differentiate this function with respect to x. So if you agree with me, it means here will be z, open bracket, z. Here will be minus y. Yeah. So that is that for coil cross vector function. Is that clear? Okay. So now we are done with this. Where is it? This. So what are we going to do? We have to do the same thing with this result. Amen. We'll do the same thing with this result. Then any final answer will now substitute in the points. So can I clean this? Any question? Please look at the board. Do you have any question? Yes or no? Please, I want you to like, comment, subscribe, and share. I'll be very grateful. Thank you. It's okay. So let's proceed. Let us proceed. So this implies that we'll do the same thing to okay. So now we are going to take this coil cross open bracket coil cross vector function now be equals to the same thing I partial all over partial x. Then our I component is here is minus open bracket x plus y. Then j partial all over partial y, true or false. Then j component is 2x. Then k is partial all over partial z. Then our k component is z minus y. Let's bracket it. Amen. Are you following? It's okay. So if you agree with me, we are going to do the same thing. It means to take the determinant of this matrix. That is one. Sorry for the break in transmission. Pokun, where are you watching from? Which country? Okay, so let's go ahead to conclude the solving. We are in progress. It's okay. So far, so good. So far, so good. So, determinant of j now will be this. Then, what are you seeing? If you close this column and this row, you are saying this, and this, true or false. So this will multiply this, then minus this will multiply minus. So partial all over partial x, open bracket z minus y, then minus times minus again. So here will be plus partial all over partial z open bracket x plus y. Then close the bracket for j components. Then we'll move further to consider k plus k. Here we cross this. So what are you seeing? You are seeing this, and this. So far, so good. This will multiply this. Open bracket, partial all over partial x. Close small bracket, 2x. Amen. Close the bracket. Then here suppose minus times minus again. Here will be plus. Then partial all over partial y. Open bracket x plus y, then close the bracket. Do you understand? Are you following? Are you following? So we can continue, right? It's okay. So far so good. I don't know whether we should. Okay, let's make use of here. But mind you, the points are 1, 1, 1, right? Okay. So far so good. Let us. Okay. Okay. Let's look at it together. Amen. So now this implies that differentiate what is here with respect to y. This will be 0. This will differentiate minus y. You have minus 1. True or false? So here will be minus 1 times I is I. Then here, with respect to z, we have 2x. So here is 0. True or false? Then here, differentiate this partially with respect to x. So there's no x here. Here is 0 automatically. True or false? Here, differentiate this with respect to z. And there's no z here. Here is 0. So j component is 0. Then here, differentiate this k component. Differentiate this with respect to x. Here is look at it. If we differentiate 2x, we are going to have 2. True or false? Then plus k open bracket 2. Then here, if you differentiate this with respect to y, you are going to have 1. True or false? So plus 1. Then it means our coil cross open bracket coil cross vector function now be equals to minus I. This plus this 3. So 3 times k. Yeah, this is what you should have. Any question, please? Any question? Do you have any question? No question? Okay. Gentlemen and ladies, since there's no question, this is where we are going to stop. Thank you for your time. I love you all. Please don't forget to like, comment, share, and subscribe to this channel. Thank you and have a wonderful red dress. Love you guys. Bye. Yeah.